In today's video, I'm going to look through your baseline assessment, and I'm just going to go through it as if I was a student and just talk you through all of my sort of thought processes for each question. So, looking at the first question, it says express 8 over root 3 subtract 1 in the form of a root 3 plus b. So I'm already looking at the form I want it in, and there's no fractions there. So what I'm going to have to do is rationalise. So what have I got? Well, I've got 8 divided by root 3 subtract 1. And to know what I'm going to rationalise this with, well, I need to multiply by the conjugate. Now, that means that I need to multiply by root 3 plus 1 over root 3 plus 1. Just check that's okay. Well, the top and the bottom are the same, so therefore it's equal to 1. So it's 8 root 3 plus 8 divided by, well, at the bottom we get a difference of 2 squares. I'll write it out so you can see. But from here, it's just going to be 8 root 3 plus 8, all divided by, well, root 3 squared is 3, 1 squared is 1, and 3 take away 1. So therefore my answer, well, that's going to be 2 at the bottom, so it's 4 root 3 plus 4. So A is equal to 4, and B is equal to 4. Okay, looking at the next question, question 2. Expressing each of the following in the form of 5 to a k. So I'm looking for my base to be 5, immediately see an error in the first one. My base is 25, and I know that 25 is 5 squared. Now from here, oh, it was power of 4, not squared. From here, we need to use the powers rule, so 5 squared to the power of 4 is 5 squared times 5 squared times 5 squared times 5 squared. So multiplying the indices, the exponents, we get 5 to the 8. Looking at the next question, I want 1 over the 4th root of 5. I know the 4th root of 5 is just 5 to the quarter, but now the issue is how do I get this to be just a singular term, not under a fraction? So the way I do that is by introducing the power to be negative. So this is 5 to the negative a quarter. And lastly, so many ways about this, but the first thing I'm going to do is just deal with the fraction, not the fraction, sorry, the inside of a bracket. 5 root 5 is the same as 5 to the power of 1 multiplied by 5 to the power of a half, which we know when we add the powers is 5 to the 3 over 2. So what I'm looking at is 5 to the 3 over 2 cubed, which is going to give me 5 to the 9 over 2, because 3 multiplied by 2, I'll write it here as well, is 9 over 2. Okay, last question on the first page, question 3. X to the 2/3, take away x to the third, take away 6 equals 0. So we need to spot something here, and we need to actually spot that this is a quadratic. It's a quadratic, and its x to the 2/3 is going to be in the place of something squared, and x to the third is in the place of something. So I'm just going to say let a equal x to the third. I'm just going to check what would a squared equal. Well, a squared would be equal to x to the third squared, which is x to the 2/3, and I'm happy with that. So what I'm going to do is I'm going to write this as a squared, subtract a, subtract 6 equals 0. This is a take away 3, a plus 2 equals 0, and I get my answers for a, like I would do for any quadratic. Okay, how do I go about it from here? Well, I know that my first step was to let a equal x to the third. So therefore, what can I do instead of this a here? Well, I can replace it with x to the third is equal to 3 or negative 2. How do I get from x to the third to x? Well, x to the third to x is going to be cubing it, so x is going to be equal to 3 cubed and negative 2 cubed, which is going to be equal to 27 and negative 8. So very well done if you got that question. Nice little substitution you might have to do to sort of unlock the whole question. Okay, moving down, looking at the next question. Apologies for that. The points A and B have coordinates 2, 1 and 5, negative 3 respectively. So how am I going to go about this? Before I even look at the question, make a little graph. 2 and 1 is going to be 2, 1 here. That's A, let's call it. And B is 5, negative 3. So let's put that down here. Okay, what do I want to know? Well, I want to know the length of a segment. So let me just quickly draw in my segment here. The length of A to B, and Well, we're just going to notice that this is going to give me a right angled triangle, so therefore I'm going to use Pythagoras. Okay, the right angled triangle for this using Pythagoras. Let's think about this. Well, it's the difference in my x's squared and the difference in my y squared. 2 and 5 has a difference of 3. 1 and negative 3 has a difference of 4. So therefore my answer, square root of 25, which is 5. Okay, the next thing, find an equation of a line through the midpoint AB, which is perpendicular to AB. Given your answer in the form of ax plus by plus c equals 0, where a, b and c are integers. Okay, lovely. So what do I need to do? I need to find some point here, which is my midpoint, and what I need to do is give the equation of a perpendicular line. Let's do it then. So, first thing I said was I needed my midpoint. Well, my midpoint is going to be halfway between, well, it's going to be halfway between my x coordinates, so 2 and 5, and it's halfway between my y coordinates, which are 1 and negative 3. To do that, you just find the average, so add them together, and halve it. 2 add 5 is 7, so it's 7 over 2, and 1 and negative 3 is negative 2, divided by 2 is negative 1, so that's my midpoint, so that's what I'm going to be using in my formula. And I need to know my gradient. Well, to work out my gradient, I have to first of all work out my gradient of a to b. So, the gradient AB is going to give me, well, m is equal to the difference in y's, so negative 3 take away 1, over the difference in x's, which is 5 take away 2. Negative 3 take away 1 is negative 4, and that's going to be 3. Okay, so that's the gradient of that line a to b, which is, how do I do this? Which way is it? No? Yeah, a to b, lovely. Okay, wait. Yeah, a to b. And I want to know the equation perpendicular. I'm not going to try and do that. But all I need to know is that it's a negative reciprocal of the gradient of a line a to b. That's the relationship between them. So the gradient of perp is, well, the negative reciprocal is going to give me 3 over 4. So, putting this straight into the formula, y subtract y1, so y take away my y coordinate, which is negative 1, so I'm going to put y plus 1, is equal to 3 over 4 lot of x, subtract 7 over 2. And it wants it in the form of ax plus by plus c equals 0. So the first thing I need to do is get rid of any fraction. So I'm going to expand it, see what my lowest denominator is, and expand up. So y plus 1 is equal to 3/4 of x. Take away, well, it's going to be 21 over 8. So I'm going to multiply everything by 8. Let me just quickly let you see that. How about that? Because you're currently hidden behind my head. Multiplying by 8, 8y plus 8 is equal to 6x, because I remember multiplying by 8, take away 21, and rearranging, I get negative 6x plus 8y, take away 20, plus 29 is equal to 0. And always nice practice, a equals negative 6, b is equal to 8, and c is equal to 29. Just going to highlight those so you can see them. But that would be the end of that question. Okay, 4 questions down, 3 more to go. Lovely little simultaneous equations question to finish off with. So, 2x plus y minus 5 equals 0, x squared minus y squared equals 3. It's always easier in these types of questions to rearrange the linear. So I'm looking at this and I'm going to rearrange it. So how am I going to do that? Well, if I add 5 and take away 2x, I get y equals 5, take away 2x. And I'm just going to literally swap this value of 5 take away 2x with the y here. So this equation is then going to give me, well, what's it going to give me? It's going to give me x squared, take away 5 take away 2x squared, and I'm going to put negative 3 equals 0, because I know at some point I'm going to want it equal to 0. So let's expand, x squared, take away, I'm going to keep this all in a bracket because I've got a negative on the outside, 25, take away 20x, plus 4x squared. Take away 3 equals 0, and now taking it all out and simplifying, I'm going to get negative 4x squared plus x squared is negative 3x squared. Negative 20x take away, so it's going to be plus 20x, and negative 25 take away 3, take away 28 is equal to 0. So therefore my equation that I'm going to work with, multiplying through by negative 1, is x squared, 3x squared, sorry, take away 20x plus 28 is equal to 0. Okay, looking at that then, whichever method you use to factorise this would be great. I'm just going to go straight into it. I think 28 is, well, what's 28? 14 times 2. 3 times 2 is 6. 14, 6 is negative 20. So it's 3x, take away 14. X take away 2, that's going to equal 0. So I get an answer for x is equal to 14 over 3, and x is equal to 2. Lovely. What do I do from here then? I've got some values of x which I'm happy with. I need to work out the corresponding values of y. So when x is equal to that, and when x is equal to that, we actually have a really nice equation we can use. So I'm just going to copy it and bring it down. This is what I'm going to use to work out the value of y. So 14 over 3 doubled is 28 over 3. 5 take away 28 over 3, it's going to give me, well, I need 15, so it's going to be negative 13 over 3. And when x equals 2, oh, much easier, I'm going to get y is equal to 1. So 14 over 3, negative 13 over 3, and 2, 1, respectively. 5 marks there. You had a bit to do, but as long as we were confident and sort of took our time with the algebra, we should have been okay. Question 6. Sketch the curve 2x squared minus x minus 3, given the coordinates of all the intersection points with the axes. So, what is it going to do? I'm going to quickly just draw out my axes, because I know that's going to be a part of it, and I want to know the intersection points. I can plot one of them straight away. When x equals 0, y is going to give me negative 3. So let's just put that here. And what else do I do? Well, I need to actually try and factorise this to get the roots. So let's look at this. 2x squared minus x minus 3 is going to factorise to give me 2x take away 3 x plus 1. So this is y equals, so therefore my roots are going to be, what's it going to be? Well, it's going to be a 3 over 2, 0, and negative 1, 0. Okay. I'm just going to make that a little bit smaller and bring it across. And I'd argue this is enough information to plot, so let's get going. 3 over 2, let's call it here. This is negative 3, and let's call negative 1, just so it's in proportion like here. And I'm going to just quickly plot a parabola. That's possibly the worst one I've ever done in my life, but let's just drag it down to make it fit nicely. Okay, there we go. I'm just going to quickly scroll down so you can see it. Hopefully you would have got something like that. Hence or otherwise solve the inequality. Well, it's this thing that I've just drawn. I'm going to call this f of x, let's say. And when this is greater than 0. So looking at the graph, when is this graph bigger than 0? Well, it's at this point and at this point. So how do we do this? Remember, if my values on the outside, I've got negative 1 and 3 over 2, and I want it to be x is less than negative 1 and x is greater than 3 over 2. Okay, looking at given that the equation 2x squared minus x minus k equals minus 3 equals k has no real roots, find the possible set of values for the constant k. Well, for it to have no real roots, what I want to happen is for my graph to move up so that every part of the graph, almost like this, is above the line. That's what I want to show. How do I do that? Well, there are a few ways you can do it. I think the way most of us would have done it is to actually use the discriminant. So we know that we want b squared minus 4ac to be, well, we want it to be less than 0. And that will show that there are no real roots. At the moment, I can't do this because my equation isn't set to 0. So using 2x squared take away x, take away 3 plus k, sorry, take away k equals 0. I'm going to get negative 1 squared, which is 1, take away 4, a is 2, and c is negative 3, negative k. And I want this to be less than 0, so it's 1 take away, well, 4 times 2 times negative 3 is positive 24, and then plus for 8k is 0. So 1 plus 24 is 25. Take that across. 8k is less than 25. K is less than 25 over 8. So that tells me two things. That tells me that my turning point here is 25 over 8, which is nice. And it also tells me that if my value of k is greater than this, well, less than this, greater than this, sorry. Should be greater than this, surely. Sorry, it should be negative 25 over 8. Yeah, so if my k is less than negative 25 over 8, then therefore it's going to move up. Okay, moving on. Last one, question 7. Nice and easy one to finish with. We've got a completing the square. So we're going to take out the 5. That's going to leave me with x squared plus 2x. And remember that this plus 2 we just leave on its own for now. Looking at this then, completing the square in the middle bit, x plus 1 squared, take away 1. And I've got this plus 2. And then getting that factor of 5 with this negative 1. 5 lots of x plus 1 squared, take away 3. So therefore p is equal to 5, q is equal to 1, and r is equal to negative 3. Okay, I hope you found this useful. If you have any questions, or undoubtedly if I've made some mistakes somewhere, then please feel free to let me know in Teams. Other than that, I'll see you in the next video.